Okay, in this video I'm going to go through a couple of D2 Edexcel Network flow questions. The first one was June 2010 and the second one dates back to is the overseas June 14, which I think is the last question. It involved a super source and a super sink problem. Okay, so let's get on with the question. First question says, state the value of the flow. Okay, well, we can see that the flow is actually given in the circle diagrams with our convection. So it's 31 plus 10, which is equal to 41. We might choose to check that these ones add up to 41 as well, and of course they do. So that's the value of the flow. Remember, it's flows circled with our convention here. Right, now we're talking about capacities of cuts. First of all, look at capacity of cut. Now when it's two on the same diagram, you have to be quite careful that you don't kind of swap between one and the other. And in order for it to be a cut, it needs to go from source to sink to contribute to the value. So that's one important thing. It needs to start off with S on the left, on one side of the arc, and with the other side being the other side, the sink side of the arc. Anything else, so for example this one doesn't contribute to the value of the cut, okay, because it's going from sink to source, it's going in the opposite direction. This one does contribute to the cut, and so does this arc here. So does this arc here, but this one doesn't, because it's going from source, it's going from sink to source, but this one does. Okay, so that's one important thing. So value of cut C1 is equal to, now remember it's capacities, that's important. Value of cut means capacity, so that's 8, it doesn't make, and that's 15, 10, that number 10 there, because it's the capacities that contribute to it. Let's take these off as I go. So we've got 8 plus 15, that one, I don't know why I said 5, it's 15, I just misread the number, and this one is 10, this one is 11, say that's 11, let's say this one doesn't contribute to the cut because it's going from sink to source, so that one's not, and this one is going from source to sink, so that's 25, and they all add up to 69. Okay, so let's just get rid of that annotation and look at the other cut. So just if you have multiple cut, if you have more than one cut on your diagram, do take care, because it's easy to go wrong and start counting numbers that don't. You could see there's my cut that I'm dealing with now. Let's mark on the numbers that contribute to the cut. Well, this one definitely does. So that's C2, that's 24. This one definitely does. That's 8. But this one doesn't, because it's going, I'm starting off at the sink side there. So that doesn't. And neither does this one, because that starts off at the sink side, but this one does, and that's 10. Remember, it's capacities. In this case, it's the same, but we must make sure we count the 24. Okay, this one doesn't count here because it's going from. Oh yes, it does. It's very easy to. Because it's going in the other direction, you've attempted to think it doesn't contribute to the cut, but of course it does. So that's plus 18. And this one does as well. That's +4. So when I look at it, I should make sure that before the arrow, for all of my ones, that they're actually all on the source side, which they are, and check if I were to include this one or this one here, I can see it would be the other way around. If I could include that one, that would be the other way around. So I have found all my numbers. So that's 32, 42, 64 is the value of that cut. Okay, right, let's now we've got something that's in the answer book. Now the network I've got would be shown in the answer book in your exam. It says by entering values DH, FH, FI and IT, complete the labeling procedure. Let's see if we can do that. Right, DH, right. Okay, just pause whilst I get the correct network up there. So we've got DH has got a flow of 18. So we could increase the flow by 18 or decrease the flow by 18 in that direction. But it's got a capacity of 24, so we could increase the flow by 6. Okay, let's rub these bits out here so I can see easier. FH has got a flow of 13, so I could increase this by 13. It's got a capacity of 15, so I can increase by 2 in that direction. Then FI has got a flow of 6, so that's 6 in that direction, and we can't increase it at all in that direction, 0. And then IT has got a flow of 10, so that's 10 now, and it's got a capacity of 15, so we could increase by 5 in that direction. Okay, so now that's part C done. Let's go on to part D. It says increase the flow by a further 4 units. You must list each flow augmenting route, and then it says prove its maximal for part E. So let's just do that. Okay, so that's better now, got plenty of room. Okay, so let's just look for some flow augmenting routes. We need to, in order to find a path, we need to make sure that none of the 4 arrows in which I'm going to are 0. So you can see there's a lot of ways I could go. I'm looking, the most obvious one I'm seeing at the moment, SBADHT. So SBADHT, and we must say what we send. Right, now we're looking for the smallest forward arrow, because that's the one we'll do. That's 2. So 2 is the most we can 2 is the most we can send along there. So send 2. So we're going to decrease the forward arrows along that route by 2. So that's 0, 0, 0, 4, and 2. And we increase the backward arrows by 2. So that's 5, 2, 8, 20, 33. Okay, but it did say increase it by 4. So there must be a, let me get rid of that now. There must be another flow augmenting route somewhere. It doesn't look all that promising, but what we've got here actually is a route that can go around the houses a bit, and this is one of the ones which would involve a backflow. S, C, G, E, D, H, T. What I mean by backflow is that if we refer back to the diagram, by increasing the flow in that direction, we may actually maybe it won't be backflow because of the direction of the original arrow. anyway, it almost doesn't matter, because so long as we follow the procedure, we can't go wrong. Now again, we're looking for the smallest forward arrow, and again it's 2, so we can send 2. So let's write the path down: S, C, G, E, D, H, T, send 2. So we're going to decrease the forward arrow by 2. So that's 2, 3, 0, 3, 2, and 0. And we increase the backward arrow by 2. So that's 32, 22, 18, 7, 22, and 35. Right, so that's it. And then I don't think we need to go any further. It is proved that it's maximal. Right, well, let's look at we can go back to the original diagram here. It doesn't ask for a final flow diagram, I don't think. Let's have a look at the original question again. Increase the flow by further stating you must list each flow augmenting route you use together with its flow. That's fine. Okay, so let's look at what's capacity. Let's look at the ones that are at capacity here. I might refer back to my original diagram again. Okay, so this again is was at capacity before. And it still is now. This has now become at capacity because it's now got a flow of 8. This is capacitated, that's 15. The flow along here has actually been decreased. There's the example of backflow we could refer to. It's actually decreased the flow. That's no longer capacitated now, because there was a flow of 2 from A to B. There's now a flow of 0 from A to B. So there's your example of backflow that I found, but anyway, it doesn't really matter. This is still at capacity here, and where else? The 15 is at capacity, the 8 is at capacity, and this is at capacity here. This is now at capacity with the 35 that we would have. This is at capacity, and those are the capacitated, and so is the 11. Okay, now we want to show the actual, now the new flow is now equal to, if you look at this, it's 35 plus 10, which is equal to 65. Basically, we've added 4 to the 61 we started with. Now, to look for a cut, we need to go through capacitated arcs that go through source and sink, and there's a very simple one there. So hopefully those, because now that's got a value of 35 for the new one. Okay. So it's basically this cut here. So the value of cut through, now you probably get away with just writing on a diagram, but I'm just going to be cautious here. HT, FI, and GI equals to 35 plus 6, which is 41, I do beg your pardon, obviously, but the original flow was 41, so we're adding 4 to that. I was getting slightly concerned that my cut was coming nowhere near. So anyway, we've got 35 plus 6 plus 4, which is equal to 45. So by, and write all 4 words here, by, we can write 45 equals 45 if you like, by maximum flow equals minimum cut theorem, the flow is maximal. Okay, so that was that question done. Okay, and that is that. Let's look at the next question, which is super source and super sink problem. So this is from June 2014 overseas. It says our question 5. And it says we've got 2 sources here. So what we do is we add this to it, we kind of make up a dummy source, if you like, or super source. Call it S. Now the total capacity has got to be equal of that. It's got to be equal to the capacities of the ones coming in, and the flows, obviously, by the conservation condition, have to be the same in as the same out. Now, presently, what we've got is these are obviously at capacity anyway, but the total capacity is obviously 32 plus 25. So the total capacity has got to be equal to 57. So we write in 57. Now I'm not sure if the original question had I think it might have been like this in the original question, so we'll add it here as well, and then I'll add it onto the labeling procedure. So the total capacity's got to be 57. So that's 57 along the arc. And because the flow along the arc is 57 as well, I've actually circled the wrong one there, but anyway, we've got 57 and 57. Now the total capacities of these are going to be 47, and the flow by the feasibility condition has got to be 24. 24. And then we do the same on the outward bit here. So the total capacity is equal to 38, but the flow is also equal to 38 because they're both saturated. And along the final one here, the total capacity is equal to 69, but the actual flow is 17 plus 26, which is 43. Okay, so that's how that one works. Now let's go, I think that's how it was for part A. And then for part B, it says enter the flow value and appropriate capacities on each arc. So that's part A done. And we've added the super source, so there we go, 3 marks. So now we're on to part B, complete the initial labeling procedure for all the arcs, the super source and all the rest of it. Well, we've got an actual flow of 57 going into the 2 super sources, and so we've got 57 there and a 0 here. We've got a 24. Let's make that clear because we're going to have to work with these numbers in a moment. So that's 24 is the flow. So we can increase that flow by 23. But there are some others missing here as well. We've got AB has got a flow of 8. So that means we could got 8 opposite to the actual flow arrow there and 0. And then we've got a flow along AD of 4, so that's 4 there, and because the capacity is 31, we've got 27 there. And then from the super source, we've got a flow of 20. The actual flow is 43. Well, I've not actually added the super source on this diagram yet. Let's do that. So coming along this one, let's do the top one first. We've got a flow of 38. So it's a 0 there because they're both at capacity. And then this one here, let's do the 29 and 26 one first. We've got a flow along D2, we've got a flow of 26, which we can increase by 3. And now let's do the final one here. We've got a flow of 43, which we could increase by the difference between 43 and 69, which is 26. Okay, so that's how it works with the super source and super sync. Now it says complete the labeling procedure in this diagram by entering values along the new arcs from S and T and along A, B, AD and DT2. I think that's what I've just done. I've done part B. We've missed out the AB. It's told us the ones that are missing. AB and AD and DD2. Yeah. And also along the super source and super sync. And then we're talking about the labeling procedure part C. Okay, so let's just magnify that so we can see it a bit better. There we go. Okay, so we're looking for flow augmenting routes here. Right, let's just find one. Let's change my color to red. So we could go S, B, E, T2 and T. Let's label that T there. Right, now let's write that out. S, S2, B, E, T2 and T. And now when we're looking to what we can send, we're looking at the forward arrows and seeing what the least number is. Got 23, 23, 13, 23 and 26, so we can send 13. Okay, so let's just do that. Change my color to blue so I'm not getting all mixed up. So we decrease the forward arrow by 13. So that goes to 10. That goes to 10. That goes to 0. That goes to 10. And that goes to 13. We increase the backward arrows by 13. So that goes to 37. That goes to 20. That goes to 12. Not 13. At 13. That goes to 18. That goes to 30. And that goes to 56. Okay. So that's the first one. Let's get rid of that. Right, okay, so let's look for another flow augmenting rate. Okay, let's try this. S, S2, B, A, D, T2, T. Remember, I just can't have any zeros along the forward arc. I'm going to actually do that again so I can write it out. So S, S2, B, A, D, T2, and T. Okay, now let's look at how many I can send along here. Remember, it's a forward arrow I'm looking for. So we've got 10, 10, 8, 27, 3, and 13. So the least of those is 3, so I can send 3 along that route. Let's change to blue here. So we've got S, S2, B, A, D, T2, and T. Send 3. Okay, so we're sending 3 along there. So let's decrease the forward arrow by 3. So that's 7, 7, 5, 24, 0, and 10. And we increase the backward arrow by 3, so that's 40, 23, 3, 7, 29 and 59. Okay. Now the nature of this is that it's always more difficult to get them as you go along, and you can be tempted to think you've got, it's normally the last one or the last one or two that are more difficult to get. There is one more we can get, and there are other combinations of, I'm sure you may have done this differently, so long as you're always choosing a route where the forward arrow doesn't involve any zeros, then you're fine. But here we go, S, B, A, D, and then E, T2, T. Right, now looking at the numbers, the forward numbers here, we've got a 7, we've got a 7, we've got a 5, we've got a 24, we've got another 5, we've got a 10, and a 10. So we can send 5 because that's the least of those. So that's S, S2, B, A, D, E, T2 and T, send 5. So we're decreasing the forward arrow by 5. So that's 7 there comes a 2. That 7 there becomes a 2. That 5 there becomes a 0. That 24 there becomes a 19. That 5 there becomes a 0. That 10 there becomes a 5, and that 10 there also becomes a 5. And we decrease the backward arrow by 5. So that becomes a 45 there. That becomes a 27 there. That becomes a 8 there. Let's write that out properly, because I'm going to actually have to write those on my diagram in a minute. 8 there. That becomes 12. The 0 there becomes 5. The 30 there becomes 35. And the 59 there becomes 64. Okay, so we have we've done it, we've completed the labeling procedure. So let's go back to see what the actual question said. So that's the labeling procedure. It says draw a maximum flow pattern on there. So I'm going to tidy this up a bit so that hopefully we can see what the question's asking us. We've got our labeling procedure here. They're asking us to do a final flow pattern which would be in the answer book, and then for part E they're asking us to prove it's maximal. So I'm just going to tidy up here and put it together so I can work easier. So notice here there's no super source and super sink, which we don't want in our final diagram because we use just those as convenience in order to use the labeling procedure, and we can't use them in edges or as part of our proof it's maximal or whatever. Anyway, let's have a look at this. The backward arrow, remember, is the one that gives us the flow. So that's 32, 25. Right, now this here, remember, it's the backward arrow that is actually determines the flow, and it's a 0. So this is again an AB. We've actually reduced the flow from the original diagram where the flow was 8. We've actually reduced it to 0. So that's what we actually mean by backflow. So then we have, this is 20 because of the 20 there, that's not being touched. AD, again the backward arrow there is 12. The for DT1, that's not been touched, so that's 18. And then BD, that's not been touched either, that's 35. Then we've got this one which has now become saturated. The backward arrow determines that, that's 18. S2, B2 there, the backward arrow determines that. That's equal to, just looking at it, I can see that should be 28. I made a mistake when we were doing it. It's 26. would have been when I initially increased it by 13, that would have been 30. Then I increased it by 3, which would have been 33. Then I increased it by 13 would have been 20. So I added 3 and only added 2, so that's 23. So it's actually 28. So my bad there. 28 is the flow along there. And then 17, 10, because it's a backward arrow. This one's not been touched either, that's 17. This one here, again, it's an example of backflow, it's 0. We did originally have a flow of 5, but it's now got a flow of 0. This one is 35, ET, and DD2 is 29. Right, okay, so, okay. That's it. It's worthwhile checking all your edges are complete, because if you miss one edge, you're going to be penalised quite heavily. So they're all complete. I would now also circle any that are saturated. So we're looking for zeros along the backward arrow. So obviously 0 is not saturated, but any numbers where, so we can see that's saturated 32. We can see that's saturated 25. And then the 17 is saturated. Just a second, you can see there's another mistake. It's so easy here. Looking at that, the flow, it's the one in the opposite direction to them, so that should be a 0, not 10. So take care. I'm really rushing this and make it, but we've got the exam tomorrow, so it's going to have to go out like this. Hopefully it's still helpful. Probably redo it for next year, but it's just the day before the 2016 exam as we go, so this will just have to go out, warts and all. So you can just see it's the number here was 0. It's the number in the opposite direction to the actual arrow here that determines the flow, so that's 0. So it's rushing this to get it done, so that's 0. Any others saturated? We've got 18 is saturated, and we've got 35 is saturated, and we've got 20 is saturated because there's a 0 there. We've also got 18 that's saturated. Right, so that's our final flow diagram. Do not put 2 numbers on each edge when you get here. We just put 1, but feel free to circle the ones that are saturated, because that makes it easy to find the minimal cut. And then the last thing is to prove it's maximal. So we can just look for a cut that goes through saturated arcs unless there's a 0 in the opposite direction. Just a second, the 29 also appears to be saturated there. So our cut can do that. Okay, so value of cut zone through, I'll put the edges, but you probably get away, if you're in a rush in the exam, you're almost certainly going to get away with not listing the arcs that the cut is going through. So don't, if there's any danger of you not completing, do not necessarily list the arcs. Always draw it, because that will always be given BE, BC, and S2, C. Now that equals to 20 plus 18 plus 29. The DE one doesn't count to it, so that's plus 18. The CB doesn't count to it, obviously, because we're going from sink to source, plus 17. Add all those together, it's 49 plus 60. Hopefully that does come to our required final flow, which is equal to 102. Now the final flow we can just look at anything from the actual sources is equal to 17 plus, we can just add these numbers together, 17, 28, 25 and 32. And that equals to 102. So that says, and do hence, when we're closing off, say hence by maximum flow, right, 102 equals to 102. So by maximum flow equals minimum cut theorem, the flow is maximal. Okay, now this is it for some of people are going to be watching this tonight for the D2 exam tomorrow. Sorry about the little rambles and the few little errors there, the 28. So, but I think we've got there in the end. There are no mistakes. So I hope you found that useful. And good luck tomorrow. Bye.